I've been making audio circuits for some time, and there is one effect, or rather concept, that keeps coming up in designs that I do. For example, the first ever PCB that I've ever ordered, that had a bunch of bugs on it, I've built it into a pedal for a friend, and that was a Tube Screamer clone. And on that Tube Screamer clone, there was one feature, a momentary foot switch, that when you press it would just short the output of the effect through a potentiometer to the input of the effect, creating a feedback loop and all sorts of noises, oscillations and squeals. I think I took that idea from some of the Fazrocious designs. Then my first commercial product as accusative is this pedal called All Animation. I have it here. And it's a crossfader, weird mixer with voltage control envelopes and LFOs. But one feature that I've put, I think, the very last moment, is this extra jack here, this extra output, which is basically a copy of the effect out that is always on. You cannot bypass it. And this jack here is specifically made to do feedback patches with that pedal. It's a lot of fun. I love feedback loopers because they can make something that you already know how it sounds and you already know how it works and make it surprise you. Sometimes it's going to be very loud, sometimes it might be even dangerous, but that's a whole new world that we can explore with pedals and patching. It's like discovering for the first time that you can patch pedals in parallel, or that you can move them around on your pedal board and plug them in different order. So recently I've been feeling a little bit burned out. I've been having too many projects with too many features. They were taking too much time, so I thought maybe I would just do something simple, something that I know how to do, but maybe at the same time put a unique spin on it. Working on a feedback looper seemed like a great idea because they can be as simple as, a couple of jacks and a potentiometer, and that's it. In fact, I think Jupiter Effects makes a pedal like that, just a passive feedback looper, maybe other brands as well. You can make it a little bit more complex, add a gain control, maybe clipping, maybe a phase switch. And for example, Fairfield does one device like that. Death by Audio makes a device like that. You can make things respond to events and control voltages and dynamics and envelopes, and that's sort of the all animation direction, but that's a little bit too complex and I didn't want to go that route. So I decided to do a feedback looper that would be simple, but at the same time would have a couple of interesting features or unique features. In fact, just to show how simple it is to make one, I have here a simple switcher with the jacks broken out and the switch just being a true bypass switch. I have a couple of pedals, and I think with 2 extra jacks and a potentiometer, I think I can build a feedback looper. Let's see. Alright, so 2 extra jacks, 2 jacks in the switcher and 1 foot switch in the switcher. The circuit is going to be passive. I'm just going to wire it up using alligator clips. Super easy. Alright, so things are a bit messy. There is a lot of alligator clips involved, but I believe this should work. So we just, send in the signal from the input, so the guitar here, into the pedal chain, and then from the pedal chain the signal goes out into the amplifier and also goes through a potentiometer back into the start of the feedback chain. Let's see if it works. Distortion. So this is no feedback. Things are shorting out. And adding feedback. Already is so much fun. What's cool about this circuit specifically is that everything affects everything. So the feedback knob affects the frequency of oscillation, the knobs on the guitar affect the frequency of oscillation. Because it's such a simple circuit, it sounds great. So let's try to plan and design a feedback looper that is maybe a little bit more complex than that, and maybe with a couple extra interesting features, but not too complex. Here we go. This is the circuit on the breadboard, or most of the circuit. It's not complete. And the clean signal is there. Let's check how it sounds. Well, let's start with the latching switch. That makes sense. So we turn it on, and then it's on. We have the volume control, which is kind of independent of what's going on in the circuit, so we can tame the feedback a little bit. We have the feedback control. Right. And then we have the momentary switch, which basically inverts whatever the latching switch is doing. So if right now the circuit is engaged, the momentary switch is gonna disengage it momentarily. When the circuit is disengaged, the momentary switch is gonna turn it on temporarily, momentarily. So at least on the breadboard, the parts of it work. It's still very noisy, and I can hear clicks whenever the switching happens. I'm not sure if that's going to be fixed on the PCB, but hopefully we'll see. Again, this is a project with low stakes. I just want to build something that is fun, that is playful, that might not be perfect, but it's still going to be very much fun to play with, I feel like. I didn't shoot this part of the process. it's quite tricky to shoot. But the important part is that nowadays I go back and forth between the capture schematic and the breadboard. I try to, whenever I make changes on the breadboard, I try to put them back into the schematic as soon as possible. And before I even start breadboarding something, I usually kick off a KiCad project and just capture the ideas in there. And that's important for me now because a couple of times I would just lose changes, or I would lose schematic ideas. So nowadays I try to commit everything to paper or to KiCad before even I start breadboarding. This is how the current file looks like. This is revision 4. Don't worry about the details. I'm going to put the schematic online on the gnd.buzz website for everyone. But this is how it looks like. There is this project for the main board, and then there is a separate project for the jacks board. This is the schematic part, and then in a similar fashion, schematic and breadboard, they sort of interact with each other, and they go back and forth, and then and then PCB and the artwork also go back and forth and interact with each other, because I would usually, before even designing PCB, I would start with the artwork. And whenever I'm doing artwork, I'm already planning the location of jacks, potentiometers, and so on. So let me quickly show you the artwork. I'm using a program called Affinity Designer, but it doesn't matter, you can use whatever you like. There is a free software version as well. What I'm doing basically with the design and the PCB, I'm going back and forth and laying out the location of potentiometers, all the sort of parts of the interface, and the prints themselves, of course. For the potentiometers and other sort of physical parts, I usually put the physical equivalent in the design as well, just so I can make sure that things do not clash with each other, that potentiometers do not sit on top of each other, and so on. This is the current version of the design, but as you can see, there has been quite a few. Oh, that looks like a cut. There have been quite a few iterations, both of the name and of the whole concept, and you can sort of see how eventually I'm converging on this version, which is there currently. And then once I have the design, I go to the PCB. And whenever I'm laying out the PCB, I always start with, defining the physical dimensions of the enclosure, just so the PCBs, do not clash with the walls of the enclosure. I start with laying down the pots and the LEDs, basically parts that are constrained physically in terms of the location by the design. So the switches, the pots, the LEDs, the foot switches. And then, I draw the board and import the components from the schematic and lay everything out. And that's it. After that, the PCB get ordered and hopefully arrive, and they are ready for assembly. And it's done. It's here. I had to force some things. I had to break a part of a PCB to fit it into the enclosure, but it's fine. I've ordered the second revision of the PCB. It should be better next time. But it works. It is here. Volume knob, gain knob, phase switch, clip switch, and then most importantly, the feedback knob. This is the latching foot switch. This is the momentary foot switch. I have a couple of pedals in the chain. Let's just try it out. When the pedal is off, we should still be passing the signal through the pedals in the chain. Now, let's try some feedback. It works! Thanks for watching. You can find everything related to the project, schematics and everything on the website gnd.buzz. You can get the pedal on the day when this video comes out. It's going to be available at Pedalmarkt. There's going to be demos as well. Check those out. And if you'd like to see more videos like this about building things and making noise, consider supporting Ground Buzz. There is a few options. You can do it on a monthly basis and get perks, extra videos, extra materials, circuits and PCBs as well. Or you can do it sort of on a one-time basis and, you know, whatever you can spare. It's going to help. Thank you so much.